today is much better for me. So hopefully maybe next week I will be fully recovered. But anyway, so we are going to continue start the main lecture of the Advanced Database Design this semester. So our goal of this class is from here to build this one. So this is the information. So information, as we discussed the last class, is a controversial still. So what is the information? For example, just like the object oriented in the object-oriented concept, when you define the object, so first from the real life, the object, you can collect the common data structure, then define the class, then instantiate the object. So this object and this object are different. The kind of the similar thing. So information in my class, the information is everything in our real life. But that cannot be managed by the computer system. Anyway, keep in mind, we are going to use a computer. So no matter what we are doing, like the AI, machine learning, the operating system, database, the program language, but this is for the computer. And the computer works for the human being, human need. Okay, so which means this information not feasible to the database system. Okay, so we try to make something change that are feasible to this computer system. That is the database design. So throughout the semester, we will talk about how to make this information. Nowadays, it's slightly changing. So nowadays, we just keep all the information to the computer system, then try to process as much as possible. That's part of the big data system, the big data, the processing. But in the database design, we try to make something changes, such as information that are feasible to our database system that are running on the computer system. So this is the information, this is the database. But this is not advanced. However, if you already took the programming class or the other computer science class, some of you guys already use the database system, like the SQL Server or the MySQL in the programming. Then, for example, SQL Server, I create the customer table, and I create the transaction table. I create the several table. Then there might be no problem. So, which means you know everything about the database. That's a small database. So, usually when we are dealing with the database, due to the limitation of the classroom activities, so we cannot create the big data, the big database. But mostly, when you create the small database, it's very simple. So we can directly create the database. You will see why it is possible later. Okay, while we are discussing about the normalization. So if you do not know what is the normalization, forget about it. So we will discuss later. But in this class, we are going to learn how to convert, how to change such just spread out the information to the database system. So step by step. First we are going to organize a little bit like this one. So this is the ER modeling. It's a conceptual modeling. Then we will create the database, the schema. It's a relational model. Finally, we can create the database. So throughout the semester, especially the first half of the semester, we will focus on how to convert such information to the database system to finally create the database system. If we create the database system, then finally we can use this database system from the application. So you learn the other program languages like the web application or the standalone system like the Java or the Python. So you are able to access such a data. And so then question. First, before we start this one, do we really need to use the database system first? So in case of large data, so which means if we have the small amount, the size of the data, sometimes, most of the time, think about your laptop. Are you using the database system on your laptop? What about the cell phone? Actually, cell phone use some of the information in the light version of the database are used. Most of the time, your laptop, so for example, I manage the friend and the contact list I'm just using Notepad. In the Notepad, I write all my friends' name and the family name and the address, the phone number. That's pretty much enough. So whenever I need, I Control F and search. Then that's pretty much enough. That's more convenient. Sometimes it's faster than the other application. Okay? So most of the time, we don't need such a database system. So especially when we have the very large data. Why? Because as we discussed the last time, this is our computer system. In the computer system, the main job of the computer system is from the CPU process the data that are stored in the memory. Okay? So from time to time, call the instruction or the data, and they process it. Okay? And what are they? It's the data. So we already use the data and the database, such a concept in our programming, in our application. Like for example, if you define the integer I as the number, and sometimes we can create the array, okay? Then sometimes we can create the what? Class, the student, or node. If you remember the data structure class, you learn what is the node, okay? Then the node has a number of fields and the number of methods. You can create a class. And if you instantiate, that will be created on the memory. Okay, then using the reference, you are able to access data. This is a database. Okay, it's a memory-based database. So we can use the memory as a database. So in case we have the reasonable size. However, the main problem of the memory is the size. Another problem is the volatile, and also it's the size. So it's not big enough to keep all the data. So when Dr. E.F. Code, we will see this guy's name later also, the Dr. E.F. Code who proposed relational database model. So then he actually proposed when we have the very large banking data, so we cannot use a memory-based database. We need something other. How can we need to use secondary storage? But to use the secondary storage, main problem of the secondary storage is what? It's slow. Comparing to the memory, it's slow. If this one is fast enough, we don't have to worry about too much. Just use this one as a memory. However, definitely there is a speed gap. So we need to do something other. Do something other means we need to consider different data structure. Okay, different organization, different format. So that's what we are going to learn throughout the semester. For that, the different data structure is called the database model. So there are a bunch of different database models, especially we are going to use a relational database model. Don't worry about the name itself, so we will learn throughout the semester. So relational database model. So if we have, this is a relational database model, and this is a conceptual level. And then finally we have the database system. So at this time, it's not at once. So when we have the very small database, intuitively we can create directly such a database system. However, most of the case, it will be very, very complicated. It will not be possible to create the 2,000 table at once. So it's not possible. So we will learn how to design and create the database from information to the database system step by step. It consists of the several steps. First, last time we talked about the difference between the data and the information. So what is the main difference between the data and information? Information is everything. Data is something what we are interested in. Somebody says important. Important is a very, very subjective. So which means what we are interested in. Okay. So what we are interested in to manage in our data. So we have a lot of information about the student. like the nice hair color or it's a short, handsome. But if we are not interested in such the information in our system, we just forget about. Instead, we try to collect some important or interested information, then collect such information from the real life, the information. That is, for example, I'd like to manage the student databases. So from the student, what I'm interested in the name, ID, and address. So this one. So I found the Lee and the 111 and the 57 Towerville Drive and James and 112 and so on. And so if I collect such the information from each student, it's very similar as the object-oriented concept. When you define the class, what you need to do is first look at each object, each real thing, right? So from each real thing, the object, you can realize there are variables like the name, ID, and address. This will be data variable of class. Remember the class has the two main parts. One is data, variable, and method. Okay? So to abstract the data, to protect the data, we can use the method. Using the function, we are able to access the data. Okay? That is the main concept of the object-oriented programming. Very similar. Okay? Very similar. So what we try to find the information that we are interested in. So here the name. So if we collect such all the student information, so we realize that there are three parts: the name, ID, and address. So this is the first student: name, ID, address. If we consider all the information about this, Lee has the very low participation to the class. This can be information, but we are not interested. If we keep such all the information, it will be messed up later. Okay, not messed up, but it's very hard to manage. Okay, each student has a different information. Okay, so to manage the huge amount of the data, very large data, we try to illustrate the information that we are going to manage. That is the name, ID, and address. So we have the name, ID, and address. Okay, and also similarly, we can have the teacher and the teacher name and the course and so on. So we try to collect. Usually I try to use the example of the such a designing process very similar as what you are doing in the room. Okay, if your room is not well organized, there might be no problem to live, but it takes a time sometimes to find the homework or the textbook. But if you collect all the information about the database course, you can collect all the database, okay, and the material and the operating system material. Then it will be easy to. So you can have the concept. So how to organize your room. So I like to organize by the subject, all the material. Similarly, I like to organize all the information about the student by the name, ID, and address, and name, ID, and address, and so on. So conceptually, so we can define student, even though there are a bunch of different information, it's a name, ID, and address. For the teacher, there are a lot of information about the teacher, but what we are interested in the name and the course, and so on. So we can find such the important information, then decide what we are going to manage. This is called the conceptual modeling. Conceptually, it's not related to the database yet. It's a conceptual. So it's kind of your plan. What information you are going to manage. Okay. So this time the most important part of such a designing is the domain knowledge, not computer science skill. Okay, so many of the time, so this kind of process from the information for the conceptual design can be processed by domain expertise, like the CPA. Because most of the real life product, the industry, they are dealing with what? Money. So they need to know how or HR. So HR manager or such a CPA, the account, they are doing such a conceptual modeling because they know how the company is organized, how the money is going on. Okay, so this is a conceptual design. However, this is better than the information. Okay, it's organized, but still, this is very far from computer system. Computer cannot understand this one. Human being can understand this. So it's well organized. Okay, so well organized. Instead of such the scattered information, so we have the student. Student has a name, ID, address, and teacher has this one. And the teacher is teaching the student, something like that. It's organized, but it's still far from the computer system. Okay, so we need to consider another model. At this time, I do not explain what is a model. Later, I will explain. So, to get close to the database, we need to something the data structure that are very close to the computer system. That is in this class we are going to use the relational database model. I will emphasize on every time that everything that we are discussing in the computer science subject are related to the data structure, how the data are organized. So this is one of the ways to organize the data. Okay, so among the bunch of different database models, so we are going to use the relational database model. Idea of the relational database model is it's a very simple idea. So actually Dr. E.F. Code proposed in 1969. It's a simple idea. We consider data as a group. That's it. What's the benefit? Data as a group. This looks like a very simple idea, even not like the idea. What is this? It's a number. It's a, how many number can you count? It's an infinity number. So, but everybody know the A plus B is B equal to B plus A. Commutative, associative, distributive root are the true in the number. Then how do you know that? It's an infinity number. Did you check everything? No. Then how we can decide the axiom or the theorem and everything regarding to the number, which is infinity. How we can deal with such an infinity number. At that time, we define this as the natural number or positive integer or real number as a set. So set is the really convenient way to deal with infinity number. So we don't have to count and consider each and every case. Instead, this is a natural number or the positive number, integer number. If the number belongs to this one, then we can prove it. So using set, we can deal with even infinity number. Similarly, so when we deal with a very large database, so if we consider each and everything, it will be overhead. It takes a long time. Instead, why don't we, even though each individual, each student has your own characteristic or the different thing, but for me, when I'm managing the student information, I'm going to consider student as the only name, ID, and address as a group. Just as simple. It doesn't matter how many students. It's a million, billion, but it's just a name, ID, address, student. Okay? So that's the idea of the relational model. So relation actually is same as the set. So group of the data. So we consider data as a group. That is the main difference from the memory base. So in for example, the object-oriented concept. So if we create the object, if we instantiate one object, that refers to only one object. It's not as a group. So whenever you access each data, each object, you need to refer. So you define product and new, and using the class product, you can instantiate. So using this reference, you can access individually. However, in this relational database model, the main problem of dealing with such data is very large. If data is small, we don't have to worry about this one. So to deal with the very large data, so we adapt the relational database model, then we can create a relational database schema. That's very close to the computer system. Okay, so close to the computer system data structure. It's a relational model. Then finally, we need a software. Database is running on the computer system, which means it's an application program. It's not exactly application program. It's anyway, it's running on top of the operating system. So it's an application program. So we need a software to create the database. So what kind of software? Like the Oracle, Informix, DB2, SQL Server, MySQL, that you know. So database management system. So DBMS is a software. However, it's a slightly different software that implements a specific database model. For example, relational database model, if the DBMS implement the relational database model, it's called RDBMS. So when you talk about I have experience, 3 years experience on RDB, that means it's a DBMS or the database. It's actually the RDBMS. So, but sometimes interchangeably we use the RDB as the same as the RDBMS. So when we talk about the DBMS, the RDB or relational database, that is the software. Okay, but that software is based on what? This relational model. So this is the overall the step how we can create the database, how to design the database. From the information, we try to build what? Conceptually. So it's just you don't have to worry about the computer science skill or the data structure, anything. Conceptually. So I'd like to organize my room by the topic, okay, subject. So this is the database, this is the operating system, this is a big data, this is the deep learning, like that. It's the idea. Okay? At that time, you don't have to have any specific skill. It's just the idea, conceptually, high level. So your plan. So this is the conceptual modeling. So until this time, it can be used for our real life. It's not only for the computer science. It can be anything. Okay, but we try to use this model to the database system. So we need to change it. But this one, this is called, at this time, by the way, for the conceptual modeling, there are different approaches. But most popular approach is the ER modeling. E represents the entity, R represents the relationship. We will learn the next week. Such an ER model is not very complicated. Okay. So problem is how to find the entity, how to find the relation. We already did. For example, from the information, we try to find the student entity. If we can find the student entity, it's done. Then if we can find another entity like the teacher, then that's done. Then we try to find such a relationship. That is an ER modeling. It's a conceptual modeling. Then convert the changes, such an ER conceptual modeling to the relational database model. Actually, such a database model, this is a data model. This is a database model. By the way, I mentioned several times the model. So what is a modeling? You have used every day probably when you are taking the computer science classes. So please do the modeling, or you need to do the conceptual modeling or physical modeling, something modeling. What is the modeling?
Like the skeleton?
Skeleton? What about the fashion model? Example? Kind of. It's a standard. Okay? So, what is the main purpose of the fashion show? To showcase the model? No. Model is the kind of standard of the person to show up the clothes, designed clothes. So mostly they are not the most beautiful woman or most handsome person. Instead, the body shape is the golden ratio or the standard. That is the model. So same thing in the computer science. So when we talk about the modeling, we try to find the standardized the structure. Okay. So data model. So we try to consider such an information to standardize in terms of data, not the database. Database is different. So data. So what is the data? Data are the important, interested, the information, collected information. That if we have a lot of data in the system, that is called a database. So this is a data model. Then when we have the many data, so it's a database model. So for the database model, the relational database model is one of the approach. There are many other database models also. So for example, one of the possible is a hierarchical database model. So very similar as the tree. For example, it's really used. There's a bank. Bank has number of branch, New York, and this, the LA, and Dallas. And each branch has the saving account, and the loan account, and the checking account, and the customer information. And same thing, like this one. This is a database model using one hierarchy. So this is called the hierarchical database model. So still, some of the banking system use the hierarchical database model. How can we access the data? We can always start from the top, the bank, and the next level, New York, and the next is the type of the account we can access. Similarly, we can access this one. This is next, get next. It's a very fast to access the specific account or specific information. Problem? I'd like to calculate the average balance of all customers in the bank. You need to access this one, you need to access this one, you need to access this one. Okay, it's not integrated. So nowadays, such an integrated statistical information are important. So this one is not very popular nowadays. This is one of the approach. It's a very fast because as you can see, and also it's simply we can implement. So using the tree structure, it's always the next and next and next one. So several levels, you can find all the information. This is one of the database model. It's a hierarchical database model. Sometimes we can use the network model, like there's a student always create the related to the course. Okay, and course is taught by the teacher, like this one. So that is a network model. And also another approach is using this concept. So we regard data as an object. Okay? So the table is the object. And we consider data as an object. That is object-oriented or DBMS. Okay? Some of the database use the object-oriented concept, but relational database is among them the most popular one. So in this class, we are going to use the relational database model. So that is the overall thing that we are going to do. So this is our goal. So among for the conceptual modeling, we are going to use the EI modeling. So maybe the next week, we will start how to do the conceptual modeling. Then convert into the relational database model. So among the different database model, we will use the relational database model, which is proposed by Dr. E.F. Code. And finally, we can create a database based on the relational model. So among the different DBMS, we will use the MySQL this time. It doesn't matter. I never used the MySQL. I do not know I prefer the SQL Server. It doesn't matter. One of the good news of the relational database management system is that they are standardized. So 70 to 80% of the functionality are the same. So if you know how to use one of these to catch up the other, it's not a big deal. So it's not a big problem. So we use the Oracle database. Oracle is the most popular. It's in the market. I think that's still more than half of the production system still based on the Oracle system. But since last semester, I'm using the Google Cloud platform, the GCP. So that doesn't support the Oracle, the database management system. So instead, we are going to use the MySQL. So which means each student will create the MySQL instance, then the practice throughout the semester, and also you will do the project. Okay, so at the end of today's class, I will introduce a little bit about the project. Okay. Any questions? That's the overall thing that we are going to do. So just the first part of the first chapter and second chapter is just an introduction. So I was a little bit fast to explain. Okay, let me use the slide to see the overall contents of the chapter 1 and 2. So this is a summary of the basic definition of the data and the database that we have discussed. So I think that's pretty much okay, except the database system. Finally, what we want to do is to build a database system. Database system is based on the data, then the other application can access it. By combining all of this is a database system. Okay, so this is our goal. Okay, so this is a very simplified diagram to represent the database environment. It is true, nowadays most of the production system in the market, they have at least 1 or 2 database instances because our data size is bigger and bigger, so file system is not good enough to manage. So this is the simplified. So we have the DBMS and store the data through the DBMS. Then the other application can access such a database system. Okay, then what is the benefit of using the database, by the way? So what if, let me change the question. What if we are not using the data? If we do not use a database system, is it possible? Yes, it's possible. Most of your laptop do not have the database. So, for example, when I manage the student information, one of the possibility is in our computer system. So we have the storage like as a file. We keep the student information in the file. Okay. So in our file, so name, comma, and the ID, comma, and address, and the new line, and so on. Then in our programming, like the C programming, we can create a